All right, let's go over how to graph data, in this case data of a ball rolling down a hill, how to graph it, how to look at our graph, how to pick what type of relationship we have based on the shape of the graph, and then how to linearize our data to verify that, and finally in this case how to use that linearization to find the acceleration of our object that's rolling down a hill. So here I have some axes drawn and I have a set of data. Notice my data is labeled with the variable and with the unit, time in seconds, and position in centimeters. So first thing I'm going to do is I'm going to label my axes here. I'm going to plot x on, or position on the y-axis and time on the x-axis. So that means on the x-axis I'm going to go from 0 to 3.4. So I'm going to scale it up to about 4. And on the y-axis I'm going to go from 0 to 120. So I'll scale it up to 120. And I'm going to get something that looks like this. Maybe. There we go. Again, make sure you have, when you graph these things, you label your axes and you also put the units that your graph is in, and then scale your numbers as best you can. You don't have to use the entire axis, but use as much of it as possible. And now I'm going to take, using my data table, I'm going to plot my data, and I get something that looks like that. So to me, it looks like it curves up. You might have noticed that I used, added an extra point. I used the point 0, 0 as part of my data, since this lab, if I let no time pass, my ball didn't go anywhere, so I was able to use the point 0, 0 as well. It just helps me to visualize what this graph actually looks like. And then when I look at it, let me just draw a line through it just so I can get an idea. It looks to me like it's a graph that kind of curves up, like maybe part of a parabola. So I'm going to look at my different types of graph styles. And I'm going to see if I can match this graph to one of these. So I know it goes up, so I can automatically get rid of the inverse graph, I can get rid of the inverse square graph, I can get rid of the inverse root graph, and I can get rid of the no relation graph. Now the other three, we have a linear, we have a square, and we have a square root graph. Now I already checked, I believe this curves, so I'm going to get rid of the linear for now because I think this thing curves. So it could either curve up or it could curve down, and my graph looks like it curves up. So I'm going to, my first guess is going to be that this is a square graph. So that means that it's going to have a relationship of y, of my y variable is equal to some constant times my x variable squared. In this case, it means I think the relationship is going to be x equals some constant. I'm going to call it m for now, just because we might use a for something else, times, and my x variable is t squared. So that's my guess for the relationship. Now this doesn't prove that because my graph is kind of curved, my data points aren't perfect. So what I want to do now is I want to, and also you might notice it's hard to, if I want to figure out what m is, it's kind of difficult for me to, without a computer, to figure out what that constant m is based on this graph. So what I want to do is I want to regraph my data so that it makes a straight line. And the way I'm going to do that is I'm going to look at my equation. So this is the equation, x equals mt squared. I'm going to keep the y variable by itself, so I'm going to keep x on my y-axis, but whatever's over here, whatever's happening to my original x variable, in this case it's being squared, I'm going to create a new variable based on that. So I'm going to create a new variable called t squared. I'm just going to take all my time data and square it. So I have a new data column that's t squared, and again, notice it's in seconds squared this time because I have to also square the units if I square the number, and I get 6 new data points. And now I'm going to graph them. And I also need to put new axes on. So I have my new axis label. This time I go from 0 to 12 first time squared, and from 0 to 122 for the position, and now I can graph my data. And it looks something like that. And if I try to draw a line through that, because I think if my guess is correct, this should be linear, I get a pretty nice straight line that goes through that. So that's called linearizing your data, where you kind of use your first graph to make a guess at what type of relationship there is, and then you regraph it you kind of create this new variable and regraph it based on that new variable. This time it was time squared, and hopefully if you were right, that new graph should be linear and should give you a straight line. Now the last thing I want to do here is I want to use this straight line to figure out what this constant m is over here. And you might notice now that if this is my y variable and t squared is my x variable, well, this just looks like the equation for a line which is y equals mx plus b. Mine goes through 0, so the b ends up going away and being 0. So really, this constant m in here is the slope of this line. Now I'm just going to go and try to pick 2 points that go through something that's useful. So if I look around, this point here kind of goes through a line that's easy to see, and right there goes through a line. So I'm going to use those two. So I'm just going to drop some lines down here so I can take the slope of this. So I kind of have a slope triangle that looks like that. Now if I look at my rise or my delta y, that's going to go from, let's see, this goes from 110 down to 10. So that's going to be 110 minus 10, which is 100 units. My delta x goes from, it looks like it's about, I don't know, 10.7 over here, and it goes down to 1. So this is going to be, my delta x is 10.7 minus 1, which is 9.7, which means my slope is going to be my change in y, 100, over my change in x, which is 9.7, and that is going to give me about 10.3. Now if I got to check on my units, so my y variable is in centimeters, my x variable, now the regraph version is in seconds squared, so that's going to be centimeters per second squared for the slope of this. Now depending on when you're watching this video, you might have learned in class that when you graph data this way, especially for something that's accelerating, the slope of this graph ends up being equal to 1/2 of the acceleration. So if I rewrite this, I can say then the acceleration equals 2 times the slope of this graph, or 2 times 10.3, or from this graph I can tell that the acceleration of my ball rolling down the hill is going to be 20.6 centimeters per second squared.